The region is purposely shaded so that it does not touch the line. X cannot be equal to y, and that is why this line that we have here, which represents the boundary line for the inequality x is greater than y, this shaded region should not touch that line, and that is why we have it, as you can see, just a little below the line. Also, for the other one, because of the less than or equal to sign, this tells us that because it can be equal to, the shaded region should actually be in contact with that boundary line. We have 4x plus 5y is less than or equal to 900 because of the or equal to attached to the inequality. Then points on the boundary line can be a part of the solution of this problem. The expression is an equation, which is this one. The point must be on this line. X plus y is equal to 200. And I'm going to be saying it early that because of the special ways that the conditions are written, then this problem is greatly restrictive, which works in favor of the students if the students can recognize this. But if the students do not recognize this, then they will have some serious difficulties solving this problem. X plus y is equal to 220. Any point that is a solution of this problem must be on this line. Now we see how a lot of the points are eliminated. Any point that we choose cannot be on this line, the dotted line. That's for sure. Additionally, any point that we choose must be on this red line. This means that all other points are eliminated and we are just restricted to a few points. As a matter of fact, we are restricted to a single point on this occasion. The problem requires the greatest values of x and y that satisfy the conditions. Because of the special cases, there is one point that qualifies. The problem is just restricted to a single possible point. How so? Because no point on this line will qualify. Additionally, any point that will qualify must be on this line. Because irrespective of what values of x and y we choose, x plus y must be equal to 200. We may consider the region common to the two inequalities, and it is clear. We can see that physically. This region, which is actually below the line y is equal to x, and of course the other region, which is below the line 4x plus 5y is equal to 900. When we shade those two regions, we see that the common region is the one that we have shaded right here, the one that is a part of the shades of both of the inequalities. Then that's not very difficult to see. So this is the region that satisfies both of these inequalities, that region. Those two vertices cannot be a part of it because they are on the line y is equal to x. Notice that we have two vertices here, which would normally be vertices to consider in a linear programming problem of this nature. But because we have this dotted line, any point that we choose cannot be on that line. Because of this inequality, x is greater than y. X cannot be equal to y. Therefore, these 2 points, a part of this line, cannot be a part of the solution. the point must be on the line x plus y is equal to 200. If we look at the region, what we will recognize is that there's only one point in this region that is on this line, and it's this point right here. Therefore, this is the only point that qualifies. There it is. We see that x is equal to 200 and y is equal to 20. That is the only line that can possibly be a part of the solution of this problem. The teacher must purchase 200 hamburgers and 20 pizzas, and that is the maximum number of pizzas and hamburgers that the teacher can purchase. As we have seen, the problem was restricted to a single point because no point on this line will qualify, and as a matter of fact, because we have x plus y is equal to 200, then the only point that is possible is this one. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.